Alright, note number 1, multiplying monomials. Alright, an exponent is a way that we can represent repeated multiplication. For example, if we have 4 to the third, it just means 4 times 4 times 4. Or we have 4 3 times, which would give us 64. Now we have some different laws with our exponents. The first one we're going to talk about is the product of a power rule. So if we have this first one, it gives our problem 2 to the third times 2 to the second. Expanded form would mean we have 2 times 2 times 2, because that's 2 to the third. And then we have 2 times 2, which is 2 to the second, which gives us a total of 5 2. So that's also 2 to the fifth power. And if we look at the next one, if we want to expand this, it's going to be 3 times 3 times 3 times 3, 3 to the fourth. Then we just have a 3, and then 3 squared is times 3 times 3. Now we have all 3, so if we count them, we have 1, 2, 3, 4, 5, 6, 7. Repeated multiplication, that would be 3 to the 7th power. If we look at the next one, well, now if I write this out, I have 10, and then I have b to the third, so that's b times b times b. Well, I have a b in the middle, so I just put that times b, and then I have 4 and b to the third, so that's times 4 again, and times b times b times b. Now when we look at this, we have a 10 here times a 4. Well, that's 10 times 4, which is 40. And now all these are other b's, so I have 1, 2, 3, 4, 5, 6, 7. So that's b to the 7th power. And then with the last one, if we write this out in expanded form, it's going to be 6 times a, that's a squared. And then b to the third is b times b times b. I have 3 b's. And then the second one is 2. And then a to the third is times a times a times a. My 3 a's, and then b, so times b. So when I go to put these together, I look at my two numbers. Well, I have 6 times 2, which will give me 12. And then we have 1, 2, 3, 4, 5 a's, so that's a to the 5th power. And then 1, 2, 3, 4 b's, which is b to the 4th power. So that's showing you how the product of the power rule actually works. Now what the product of the power rule is, we don't have to write it in the expanded form to get our exponential form. We can skip that step, and we can just say that to multiply two powers that have the same base, we add the exponents. So to multiply two powers with the same base, we add the exponents. So we add the exponents. And what that means, if we have something like a to the m times a to the n, well, the a's are the same. That's the like base. That's like our b's up here, or the 3's or the 2's. Well, that's going to give us a to the m plus m. And an example, we actually just looked at a bunch, but let's say that we have a to the 4th times a to the 5th. Well, that gives us 4 plus 5, which will give us a to the 9th. So that is the product of power rules. And we can look at a couple examples here that we have. Now when we look at this, it's 4 to the third times 4 to the second times 4. Well, I'm going to put a 1 on that last one because it shows me 4 to the first. Well, if we add all these, so it's 3 plus 2 plus 1, which is going to give me 4 to the 6th power. And later on, we're going to evaluate that, and we're going to say it's 4 times 4 times 4 times 4 times 4, 6 times. When we look at number 2, we have 3 plus 4 plus 5, so that's going to give me x to the 12th power. We'll look at the next example. Now here, we want to group our a's. So I have a to the 2nd and a to the 5th, which will give me a to the 7th. But I also have some b's here. I have b to the 2nd and b to the 3rd, which will give me b to the 5th. So my final answer, a to the 7th and b to the 5th. So I put my a's together and I put my b's together. I don't put the a's and the b's together. We combine just the like terms, the like bases. When we look at number 4, well, we put our numbers together. So we do 2 times 4 we group our numbers, and then we group our x's, x to the third and x to the fifth. Well, 2 times 4 is going to give me 8. And when we add these, 3 plus 5 is 8, so it's 8x to the 8th. When we get to number 5, now once again, we group our numbers. So I have a 3 and a 5. Now I group my a's. Well, that's an a squared and an a to the third. That's a multiplication. And then we group our b's. Well, it's b to the 7th times b to the negative third. Well, we simply multiply these out. Well, this 3 times 5 is 15. 2 plus 3, a to the 5th. 7 plus negative 3 is 4. 15, a to the 5th, b to the 4th. And now number 6, we do all the same steps. We group our numbers. So I have 2 times 3 times 4. Now I have w's, x's, and y's. So I'll put my w's. I have a w and w to the third. I'm going to put a 1 above that one. X's, I have an x squared and an x to the third. And then y's, we have a y and a y to the third. I'm going to put a 1 above the first one. Now we simply multiply. Well, 2 times 3 is 6. 6 times 4, we have 24. We add 1 plus 3, so we have w to the 4th. We add, and 2 plus 3 is 5, so we have x to the 5th. And then 1 plus 3 is 4, so it's y to the 4th. And then 7 and 8, it's just the same process. It just gives it in the form of a problem. Well, we know to find the area of these shapes, we do length times width. So I have 5x to the 4th times 2x squared. Well, I group my numbers. 5 times 2. X to the 4th times x squared. So it's 10x to the 6th. We add our exponents. And for the triangle, it's base times height divided by 2. Well, the base, so I have 6ab to the third times 4a squared b, and then I divide it by 2. Well, if I group my numbers, it's going to be 6 times 4 divided by 2. And put our a's, which is a to the first times a to the second. And we group our b's, b to the third times b to the first. And 6 times 4 is 24, divided by 2 will give me 12. Add my a's, 1 plus 2 is 3. And then add the b's, 3 plus 1 is 4. So we get 12, a to the third, b to the fourth. Now if we flip this over, the next thing we're talking about is power of a power rule. Now once again, we just have expanded form. Well, what this means is that I'm going to have 7 to the second 3 times, which is going to give me a whole lot of 7s. So I have 1, 2, 3, 4, 5, 6, so it's 7 to the 6th power. Then we have a to the third 4 times. Well, if I have a to the third, and a to the third, and a to the third, and a to the third, I don't have enough room to write all these out, but using the last thing, I know that I can add 3 plus 3 plus 3 plus 3, which will give me a to the 12th. And then the last one, x to the 4th to the second, well, that's going to say I'm going to have x to the 4th 2 times, and I know that I can add these. Well, 4 plus 2 will give me x to the 8th. So now we can get a second rule, which is to find the power of a power. We simply multiply the exponent. So that's what we're really doing. So a power to a power, we multiply the exponents. So if we look at this, we just do 2 times 3 will give me that 6. And 3 times 4 give me the 12. And then 4 times 2 gives me that 8. So we multiply the exponent. So an example, the generic example, so if I have a to the m to the n, that'll be a to the m times n. Or if we just use our example before, if I have a to the third to the second, it gives us a to the third times 2, which is a to the 6th. So when we look at 1, 2, and 3, we simply just multiply these two exponents, so it's 6 to the 8th, x to the 6th, and 5 to the 20th. It's 4 times 5, so 5 to the 20th. So that's the power of a power rule. And then we get to the power of a product rule. Well, what this means is that if we look at this, we simply write everything in the parentheses 4 times. So if I write this out 4 times, what I notice is here I have 4 x's and 4 y's, so it's going to be x to the 4th and y to the 4th. If I write this, I write everything 3 times. So I'm writing everything in the parentheses 3 times. So that, or I wrote that 4, so let me erase this last one. So I write everything in the parentheses 3 times because that's what the exponent means. So now I have 6 3's, so 6 to the 3rd, 3 a's, a to the 3rd, and 3 b's. And then if we look at the next one, we have 8x to the 4th. So I'm going to write this 4 times. So that means I have 4 8's. So it's 8 to the 4th. If we add these 4 plus 4 plus 4 plus 4 will give me x to the 16th. And the last one, I have 5 w to the 2nd, p to the 3rd, and I have to write this 3 times. It's a whole lot of writing. So hopefully there's an easier way to do this. Instead of writing out in expanded form, we have 3 5's. We have 2 plus 2 plus 2, that's 6 w's. And 3 plus 3 plus 3 p's, which will give me p to the 9th. So what the power of a product rule is saying is that to find the power of a product, we find the power of each factor and multiply. So each factor, each number inside the parentheses, we multiply. So we want to find the power of each factor. So we find the power of each factor and multiply. So it's taking the last one, doing it one step farther. We just are adding extra factors inside. So we multiply each thing, or we distribute the exponent to everything inside. So our example would be if we have a to the b to the m, it's going to be a to the m and b to the m. Or if I have xy to the 4th, it's going to be x to the 4th and y to the 4th. So it's kind of like the distributive property, except it's with the exponents. So we're taking this and raising everything inside. So it's going to be 4 to the 2nd power, a to the 2nd power, and b to the 2nd power. Next one, we do everything inside. So it's 5 to the 3rd, c to the 3rd, and d, what was this one in here? So it's, we multiply. So 4 times 3, give me 12. And with this last one, well, I have negative 3 to the 3rd power. Now, it's a negative, so I put that whole thing inside parentheses. And we're going to talk about that later on why that's why it has to be in a parenthesis. And we multiply it, so 2 times 3 is 6, so it's x to the 6th. And 2 times 3 here is going to be y to the 6th. And that is our power of a product rule. So we looked at 3 rules today: the power of a product, the power of a power, and also the product of a power.